Hello and welcome to my Physics 2212 Lab 1. So today I'll be talking about the behavior of electric charge and mechanically charged tape. So to begin with, let me introduce a small model, Coulomb's law, which basically states that a force generated by electric charge is proportional to the constant K, which is derived from the free emissivity constant and is also inversely proportional to the square of the distance between the two objects with the charge. So the main result of this lab is that by mechanically charging a piece of tape, it is possible to observe a visible deflection of the tape when exposed to other charged objects. So the main ideas that are being explored in this lab are electric force, which is used to calculate force applied on the upper tape by the lower tape, gravitational force, which is dependent on the inverse square of distance and directly on mass. It can be approximated as Fg is equal to mg, where g is 9.81 meters per second squared on Earth. So the system is the upper tape getting lifted, and the surroundings are the lower tape as well as the Earth for gravity purposes. The experiment is conducted by taking two pieces of tape and charging them by layering them on a base tape and taking them off to cause mechanical transfer of charges. These charges are checked for charge by hanging them off of a table, moving a charged object nearby, and observing a deflection. Finally, one charged tape is held under another. As both are charged, the tapes will repel each other, causing the upper tape to hover. So to code the solution out, I created this code. It basically calculates the force based on distance and mass of tape. So the calculated charge is 9.78888 times 10 to the negative 11th coulombs. And the assumptions are that air resistance was ignored. Both tapes were considered point charges, and each tape had similar charge and mass. To compare, the results are mostly similar. Electric force is minuscule in reality and computationally similar with gravity. And gravity is also small due to low mass. So the potential sources of error that I discovered were the mass of tape is estimated based on the length. Basically, we're given a standard unit of measurement for mass based on the length of the tape, and that was likely not correct. I wasn't able to use a scale to measure the mass of the tape. Handling the tape can cause a charge to leach off, and small deflections could be in either direction, which could result in misidentification of tape charge. So what does it mean? Basically, if the electrons and the protons are swapped charges, the direction of forces would end up staying the same. The electrons would transfer out of the tape still, which is likely what caused the tapes to be positively charged, as was observed by the tests. And the tape would instead become negatively charged. However, both tapes would equally become negatively charged, so they'd still repel each other. The other question is why handling the tape is very important. Handling the tape correctly allows electrons to transfer back in to the tape if you do it incorrectly, causing the charge to be lost. Therefore, the electric force will no longer be observable. That should be all from me. Thanks for watching, and have a good week.